Group 1 Chemical Properties Forming Cations by KayScience.com. Here is a simplified periodic table where Group 1 metals can be found to the far left. Group 1 metals are also known as the alkali metals. Here I'm drawing the stepped line. To the right are the nonmetals and to the left are the metals. We know Group 1 elements are metals because they are to the left of the stepped line. The order of elements in Group 1 from top to bottom are lithium, sodium, potassium, followed by rubidium, then cesium, and finally francium. You can see the mass number increases as you go down the group. Therefore, the size of the atom increases as you go down the group. Alkali metals have similar chemical and physical properties. This means they all react and behave in a similar way. When the alkali metals are pure and unreacted, they are metals. Therefore, they have metallic bonding. Alkali metals react with nonmetals. This forms ionic compounds which have ionic bonding. As Group 1 metals are metals, there is no covalent bonding. It's really important you're able to look at the periodic table, see which elements are bonded in the chemical substance, whether they're to the left of the stepped line or to the right of the stepped line, and then to be able to identify what type of bonding does the substance have. If it is just metallic atoms, it is metallic bonding. If the substance has metal and non-metal atoms, then it has ionic bonding. And if the substance just has non-metal atoms, then it will only have covalent bonding. It's question time. Attempt these questions to check your understanding. Alkali metals are very reactive. Just like all elements, the atomic structure controls reactivity. And what do I mean by this? Well, alkali metals are in Group 1 of the periodic table. This is because alkali metals have one electron in their outer shell. So if we take a look at the atomic structure of the first three elements in Group 1, we'll see lithium has one electron in its outer shell, sodium has one electron in its outer shell, and potassium has one electron in its outer shell. Remember, an atom is not stable if it does not have a full outer shell of electrons. Therefore, each one of these atoms needs to lose one electron to be stable. Alkali metals easily react with nonmetals, forming 1+ ions. The reactivity of these Group 1 metals changes as you go down the group, but you can learn about this in another video which will go into much more detail. Alkali metals react with oxygen, forming oxides, for example, lithium oxide. Alkali metals also react with chlorine, forming metal chlorides, for example, sodium chloride. And alkali metals easily react with water, forming metal hydroxides, for example, potassium hydroxide. Remember, because a metal has reacted with a nonmetal, ionic compounds are formed. These have ionic bonds, and overall the structure is a giant ionic lattice structure. It's question time. Attempt these questions to check your understanding. So Group 1 atoms lose one electron to be stable. We're now going to build on our understanding of the atomic structure of alkali metals to understand how they react. Lithium has an atomic number of 3, therefore it has 3 electrons. We can write the electronic configuration as 2.1. This will help us to draw the electronic configuration below. The lithium atom loses one electron to become stable. Therefore, it now becomes a cation, which has a charge of 1+. And we can write the electronic configuration as 2 square brackets plus. The atom has become a cation, and we can use a half equation to show this. So we write Li goes to Li plus the electron. Li represents the atom, Li plus represents the cation, and the E minus represents the lost electron. All group 1 elements lose one electron to become a stable cation. Using this as a model and what we've learnt from previous videos, pause now to see if you can draw the electronic configuration of a sodium and potassium atom, the cation, and the half equation to show how the atom has become a cation, including the lost electron. And the answers will follow. Notice how with each group 1 element, they all lose one electron each to have a full outer shell of electrons. This is shown in the electronic configuration of the cations, and this is also shown in the half equation. It's question time. Attempt these questions to check your understanding. Pause the video here to practice the keywords. The answers will follow. Press pause to answer the questions. The answers will follow. If stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes. And don't forget to visit KayScience.com for more videos, worksheets and quizzes at KayScience.com. And don't forget to like and subscribe.